So we have this special tool called the radical product rule. The radical product rule we've been using to pull radicals apart and simplify, but we can also use it to put radicals together. Okay, so we're going to use it both ways. What is the radical product rule? Let's remember that. The radical product rule says the square root of A times the square root of B times, now this is multiplication, is the square root of AB. This does not work for addition, but it only works for multiplication. You can put it under one square root. Okay, and we can either take that and use that to pull it apart or put them together. So here we got 5 square root of 2 times 3 square root of 6. Well, what operation is in between here? Remember, that's multiplied, right? 5 square root of 2 just means 5 times the square root of 2. 3 square root of 6 means 3 times the square root of 6. So we have 5 times the square root of 2 times 3 times the square root of 6. Okay? And since multiplication is commutative, we can flip that around. We usually won't write this step, but I'll write it out this time so we can see. Okay? And now we can see, well, we know what 5 times 3 is. That's 15. And we know what the square root of 2 times the square root of 6 is. We can multiply that. That's the square root of 12. Okay? So what happened? We multiplied the numbers under the square root and multiplied the number outside the square root. Okay? Now, we're going to simplify this square root of 12. The square root of 12 is the square root of 4 times the square root of 3. And the 15 is just hanging out. What is the square root of 4? Well, it's 2. And 15 times 2 is 30. All right? So, once again, we multiplied the numbers under the radical to get the square root of 12. Multiplied the numbers outside to get 15. Again, we took time to reorder it here. We'll skip these 2 steps there from now on, but that's really what's going on. Okay? Same thing for cube roots or any roots. So we could rearrange just like we did, but we don't need to. This is all multiplied. 6 times 4 is 24. And then underneath here, all right, now I'm going to write this a little differently here, okay? I'm just going to write 18 times 6. I'll show you why in a second. Okay, and then x squared times x to the 5th is x to the 7th. Okay, so 18 times 6, well, I guess it's not that big of a number. What's 18 times 6? That's 60, and 6 times 8 is 48. That's 108. Yeah, okay. So, well, it's kind of big. Let's leave it there. All right. Because that 108 is kind of a big number, okay? And so this is a good time to use the factoring, okay? So if we write this out here, all right? So we have 18. 18 is 2 times 9, and 9 is 3 times 3, right? And we know that 6 is 2 times 3, okay? So this is a good opportunity to write this out as 18 is 2 times 3 times 3, okay? And 6 is 2 times 3, okay? So let's kind of group that, okay? It's kind of a sloppy way to write it here. So we really have 2 squared, 3 to the 3rd, x to the 7th, okay? Now we kind of cleaned it up. Now treat these things just like we did with the variables, okay? We're gonna figure out what we can simplify and what we can't. 24 is gonna just hang out. We're gonna break it up into 2 radicals, what we can and what we can't simplify. Well, I can simplify the cube root of 3 to the 3rd because that's just gonna be 3. We can cube root x to the 6th because 6 is a multiple of 3. And what's left over? Well, I have this 2 squared I haven't dealt with. And this is x to the 7th. And I put 6 of them underneath here. So I need x to the 1st left behind. Things we can cube root and things we can't. Now let's just clean it up. and we're done. So we have the cube roots here. So that 3 is going to kind of cancel with that, okay? And is going to cancel with this, leaving 2 behind. 6 divided by 3 is 2, okay? If you want to write this out as x to the third times x to the third, you kind of get the same thing. So I have 24 times 1 factor of 3 times 2 factors of x, or x squared. And the leftover there is the cube root of 2 squared, which is 4 times x. Let's take that one step further. 3 times 24 is 72, right? Times the cube root of 4x. All right. Kind of a lot going on there. That one's a lot of simplifying there in the end. So once again, we just put it together. If you want to write this as 108, that's fine. You can kind of break it up from there. Okay. What we end up with 72x squared times the cube root of x, 4x. Okay. So here's another one. So if we have large radicals, it's difficult to find the largest perfect square, right? Okay, so the key here, again, is to use this prime factorization first, okay? And write it out, write that radicand in factored form, all right? And you can treat those coefficients the same way like variables. Okay, so let's see what that is. So what does this mean? So first thing is we can multiply this all together, okay? And let's go ahead and write this out. This is 12 is 2 times 6, which is 2 times 3. Okay, so let's write this. See, we could go ahead and multiply 12 times 26 times 39, but that's a huge number. I don't even know what it is, and I don't want to go there because that's just going to be ugly. So 12 is 2 squared times 3. And let's copy on the x cubed, y squared. 26 is 2 times 13. All right, so this is 2 times 13 times x squared times y. And this is 3 times 13. All right, and so 3 times 13 times x times y squared. All right. So now we're going to multiply this all together and put it under one radical. And let's just treat the numbers like variables. So we have 2 squared times 2 to the first. Well, that's 2 to the third power. Now, by the way, you'll see some videos write this out, 2 times 2 times 2. You can write it out if you like, that's fine. But, this goes a little bit further because if this was 2 to the 30th, you'd want to write out 32s, okay? And so if we can work with the powers, then it's much more powerful, pun intended. So rather than writing out a whole bunch of 2's, okay, we have 3 factors of 2. We know what that means. I have a 3 there times this 3 here. So that's 3 squared. We have a 13 times a 13. Okay, and by the way, you want to kind of keep track of all these. I've got the 13 times the 13. So you can underline them or something like that. It's not a bad idea. 13 squared. How about the x's? X to the third power, x to the second power, x to the first power. Add those up. 3 plus 2 plus 1. That's 6. X to the sixth. Then we have our y's, y squared, y to the first, y squared, that's y to the fifth power. Okay? Now again, we don't want to combine this yet because now we're going to do our simplifying. We're breaking it into 2 radicals. What we can simplify and what we can't. How about the 2's? Well, we can simplify 2 squared, but not 2 to the third. So I need to leave 1, 2 in the leftover category here. 3 squared, we can simplify the square root of 3 squared, right? Whoops. Let's go 3 squared. Okay, we can deal with that. We can simplify 13 squared, no leftovers. We can simplify the square root of x to the 6 because that's an even number. 6 is divisible by the index of 2. Little invisible index of 2, square root. If you want to put your little index, you can. This is not an even number. It's got to be divisible by 2. So the most y's we can simplify is y to the 4th. And we'll have y to the 1st left over. All right? There we go. And now, so simplifying that up, we'll simplify this radical here. We have 2 to the 1st power. Divide this 2 by 2. Divide this 2 by 2 times 3 to the 1st power times 13 to the 1st power. Then we got 6 divided by 2. In other words, the square root of x to the 6 is x to the 3rd. The square root of y to the 4th is y to the 2nd. The indices, or the exponents get divided by the index. All right, and then we have the square root of 2y. Almost there. Let's just multiply that up. That's 2 times 3, which is 6. 6 times 13 is 78. There it is. Okay, kind of a big one there, but breaking it up, keeping it in factored form there can help. All right? All right. So next we're going to look at what if we have 2 or more terms in the radical.